So, as Chad has already extensively talked about the different configurations here at ALCF, we have the Pod64, which is essentially that we have 64 IPUs that are segregated or segmented over four different nodes. Each Bow 2000, and totally we have a 16 Bow 2000 blades here, and which has pretty much a memory of around 60 GB in processor memory, and up to 4 terabytes of streaming memory. So as you see here, we have total of 64 IPUs, and that is segregated over 4 compute nodes, and all the 4 nodes are named as follows. As you see on the screen, it's GC Poplar from 01, on 02, 03, and 04. So you can access either of these compute nodes, or you can put together the IPUs associated with these compute nodes together. And in shortly, we'll take a look at how to do that. So the first step for actually accessing the system is to request for an ALCF account. I know a lot of users here have probably already have an existing ALCF accounts, but any new user who do not have their ALCF account yet can request one using the accounts page here. You can take a look at the snapshot that's on the left-hand side of your screen. And you need an active project to request for an allocation. Any help that is required in getting your access to the system or in general an ALCF account, please do reach out at the following email of accounts@alcf.anl.gov. So once you have the ALCF account, the second step is to actually join the particular project. So for this system and for this particular training, we use the GC_training project. Go on to the project available projects, and you can search for this particular project title, and you can see it'll list you the one, and you can request for the membership on that particular project. Once you are granted access, you can go on to the request and view systems in the same page, and you will see that the graph core is part of the available resources and the currently whichever you have been enrolled for. So once you see that graph core is added onto that list, it's now you're pretty much ready to go and access the system. So once you have all the access requirements done, the next step is to actually log in to a compute node. So if you can see the snapshot here, so you are on your, say, local machine. So the step to actually reach the compute node is a 2-step process. The first step is to log into what is called as a login node from your local machine. So there are 2 login nodes at this point of time, GC login 01 or GC login 02. You can choose either of these login nodes to log in to those graph core login machines. So this typically takes a password that is a 8-digit token that is actually regenerated using the Mobile Pass Plus app on your phone. So set up this particular app before you want to access the system. The steps that is required to install this particular app is present on the ALCF website. We can provide the particular instructions on that if required. And please feel free to reach out if you have any issues or concerns. So once log into the login node, then that is the place where you can log in to the next. You can choose to log into whichever compute node you want. So currently, if you see the snapshot there, you have three compute GC compute nodes that you can access directly or log into, which is the 02, 03, and 04. Currently, as you can see, that the GC popular node 1 is not accessible directly to the users because it is also associated with some of the management activities. So you cannot directly log into the GC node 1. But having said that, any IPUs that are associated with the GC Poplar 1 can easily be accessed by the other compute nodes using because the Slurm basically is a resource allocation manager that actually assigns those particular IPUs to your runs. So these are essentially the steps required to log on to the compute nodes. Before I move on to speaking about the environment setup, the GC training allocation or the active projects will be active until the August 10th. And having said that, there is a data center shutdown from this Thursday until probably next Tuesday. So you will not be able to access the systems during that period. And once the systems are up, you will obviously receive a mail once they are up if you're part of the mailing group. And you can still continue to use this GC training active project actively until, say, August 10th. So as a next step, so once we have logged on to the system, the Poplar SDK that we have learned about in our previous session is currently present at /software graph core and Poplar SDK. So there are usually the different versions of these Poplar SDKs are downloaded and they're placed at this particular directory. Currently, we have, so the default SDK will already be enabled on the login. So currently it is at 3.1, but if you see that particular directory tree, you can also see that there is a 3.20 that's also downloaded and you can use that. But having said that, that's the new GraphCore release is 3.3.0, which we expect to be our systems to be upgraded to probably in a few weeks from now. So bear with us until that. And the most tested version at this point of time is 3.1.0. And you can choose that version and try to work on it. So once once the SDK is enabled, you can check using a POP-C version, and it will list you which version of the Poplar that is being enabled. And you can see as an example that's present on the screen. And another way to actually enable an SDK is source that particular the version of the Poplar SDK that you want. And in case you have been using or some other Poplar SDK version is being set, but you want to use another SDK version, then first unset using this command, like unset Poplar SDK enable, So that will flush out whatever settings that is required that was there by the previous SDK, and you can source the required SDK version that you want. So that is the way to enable the Poplar onto your um, system. And an important is how to set up the environment variables. So before you can start with any of your runs, I suggest that you set all these environment variables. It'll help you to set these cache, these flags, and also the cache directory, so that so once these cache directories are set, basically, if you once the first time you run a model, it will take a considerable amount of time depending upon the model size to compile. But with this flags enabled, it will store the compile artifacts. And if you want to reuse them at a later stage, your compile times are very, very short. And it'll help you to fasten up your training activities. So as part of the workflow, as we have seen, compile and run is pretty much essential for any of enabling these AI models running on the accelerators. So with GraphCore, whenever you use the scripts to run the model, the whenever you see a Poplar training model options, it will compile the first time. And as I said, if already the compile artifacts are present, it will reuse it, and then the training of the model will start. So the recompiles usually happen only if there is any model parameter change, or if the cache directory is not set. I know Alex has gone through extensively on the GraphCore repository, but here is a snapshot of the GraphCore examples that encompasses a lot of different and varied applications, from NLP or CV models or GNN specifically. So you can take a look at these, and usually these are a good starting point for you to kind of run and access the systems and learn in depth about GraphCore. You can just git clone them. It's a open source repository, so you don't have no need of any username or access problems or any passwords that is associated with it. So you can directly git clone on the login node or on the compute node, and you will have all these examples to run. So just a quick review of how to run a most simplest program. You have the MNIST example. It's part of the GraphCore examples tutorials, and this is a PyTorch application. So as part of the first step, you just activate the environment. The steps to actually generate the environment is provided on the ALCF website, and it's pretty much specific to each of the models that is required to run. So you can either refer to the ALCF websites for a smaller subset of the applications, or you can also choose to refer the exhaustive directory of the GraphCore examples, which also enlists how to build a GraphCore virtual environment. So once you activate the environment, you can install any specific packages that is required for that particular application. And for MNIST, you can see that there is the snapshot of the different parameters or command arguments that are associated with this particular model. pretty much everything is self-explanatory with the kind of arguments that is there. The batch size, which in this case it defaults to 8. As Alex was explaining earlier, the device iterations is a very unique feature, I must say, for GraphCore, where you can move 50 batches of data from the host to the device, and it unless and until all the 50 batches of data have been completed, you don't have to refer back to the host or the CPU here, and that was good performance optimizations involved in this particular model. And in general, you will see that this has been extensively used in a lot of in most of the models, I must say. And this also talks about what's the learning rate, what's the number of epochs. Of course, you can change it accordingly and pass it through as arguments for the command, which we will see shortly. And just to recap from what Alex said, so if you're converting a PyTorch model to a PopTorch, obviously using this PopTorch.options will actually set the tone to convert a usual PyTorch model to a PopTorch that is enabled with its optimizations. And the training model that I was talking about earlier is when the first time it sees this particular part of the code is when the compile happens, and then subsequently you have the different training epochs that will follow. So having seen the inner details of this particular model, so how to run this model on our system? It's a simple. We use a Slurm resource manager to actually run these scripts, because we have multiple users accessing the same systems, and Slurm allocates the different resources here in terms of the IPUs that you request. So please do use the Slurm srun command, and you will see that unless and until you use that, you will not be allocated any of the resources on the system. So the options for the srun is, the main option is actually the number of IPUs that you want to use. In this particular example, we see that it's just requesting just one IPU, and then followed by a simple Python and a script command. Of course, you can increase the number of IPUs that you want to request, and of course use different command arguments as you choose. But essentially, this is a basic and a crisp command at your disposal, where you have the srun, the number of IPUs, and actually the Python script that you want to follow it with. So as I said, when you run this, you will see the graph compilation happening. The first time, it might take a bit longer, but subsequently, if you have the cache set up, the compilation is pretty fast, and you can observe that in amongst your runs. So the extension for whatever we saw until now is a very simple MS program that's using just one particular IPU, but you can also extend and use the system for much more advanced models, like say GPT models. And here is an example of a GPT-2 model, and the path to this is provided here, and is part of the GraphCore examples tree that you can find under the NLP directory. As any other model, the first step is to activate the virtual environment that you want to work with. install any particular packages that are specific to the model under consideration. And particularly for this model, again, this is a PyTorch example, a GPT-2 model. So the first part would be the SRun, as we have seen. And here we use a total of 16 IPUs. So basically, the IPUs is the total number of the resources that you will be using. But as you can see, the ones here that are highlighted in red are one of the important parameters that you need to consider. So this particular example works where an entire model fits on, say, 4 IPUs, which is suggested by the IPUs per um, replica. replica. Sorry. So an entire GPT model uses as much as like 4 different IPUs here. And then we are replicating that 4 times in a data parallel fashion. So 4 IPUs in each replica and total of 4 replicas, which obviously maps to 16 IPUs. So please be mindful of the correct number of IPUs that you are requesting. Currently, with the topology under consideration, you can go as minimum as say 1, 2, and multiples of 2, in fact, like 4, 16, and even if you want, you can use the entire 64 IPUs. But at this point of time, we do not support a 32, say, configuration of IPUs when you have like a replica of, say, 4. IPUs per replica is 4. So that please be mindful of that, that there are some restrictions in terms of the topology that we have. So this is the main 2 important command arguments that I wanted to highlight, which essentially will help you to set up a data parallel run. And of course, there is a inherently model parallel of a particular model that spans across different IPUs. The other command arguments are pretty general, like gradient accumulation and device iterations. We already spoke earlier, and batch size of 1, which is like a micro batch size. The layers per IPU suggests how do you translate your entire model or different layers of your model, and how do you place on which IPUs as such. And the other arguments are more specific to the model, and some of them are as like self-explanatory, like the number of epochs that you want to work with. This particular example is being is using a synthetic data set that is indicated by the generated argument, but you can choose to set up your own example data set and use the same model to ensure, but do ensure that they're of the same sequence length and so on. So how do you calculate the global batch size is the next question. So which is pretty straightforward in terms of the you consider the micro batch size and the gradient accumulation, and also the replication factor here. So this is like a small example of so this runs on, say, Pod64, and you can essentially change the parameters to suit your own model, or if you want to change the total number of replicas that you want to wish, and then choose your own run setup. I would, last but not the least, I would also want to talk about the utility commands. We saw that srun is an important part of launching any of your scripts. Unless and until you do that, you will not be able to access any of the resources on the system. So Another important command is the SQ. You will, which is pretty familiar for people who've used Slurm in the past. So this will essentially tell you what are the different jobs that your users are using or running on the system. You can also see whether we have any resources that is pending or allocated in kind of the status of the different jobs in the queue. You can also use scancel to cancel an existing job, and nsinfo provides you the partition and the node information associated with it. So these are typically the main commands that you will be using in general when you're trying to bring up a model on the system. But you can always refer to the Slurm documents for any exhaustive, list of commands and what are the different help options for it. Another important tool that is required to, get some information on the cards, the GC monitor. You can see here that you need to set up set this flag to the required IP address. And when that is done, you can use the GC monitor in another window when something is running, and you can see what are the different kind of applications, which compute node is being used. What is the if you see that the power and the temperature is elevated when compared to the normal sense, that means some computations are happening on that particular node. And you can check the flops, that the clock rate there, and it provides more information on all the different aspects of the node.